Today we are going to discuss the last part of the cardiac cycle. In the first part of the cardiac cycle, I discussed about the 5 stages of one cardiac cycle. In the next part, I am discussing about the electrical stimulation. And in the third part, I combine these two parts. That means how electrical stimulation correlated with this systole or diastole. Okay. Already I draw a rough diagram. So this one. First I will start with joint diastole. Joint diastole. Joint diastole it is occur for 0.4 second. Out of total cardiac cycle time is one cardiac cycle time is 0.8 second. Out of this 0.8 second, 0.4 second is for joint diastole. And during joint diastole, all these chambers, this is suppose right atrium, this is right ventricle, left atrium, left ventricle, these are all in relaxed position. So in that time, from superior vena cava, then inferior vena cava, then coronary sinus, this all carry deoxygenated blood to right atrium, when it is in relaxed position. Also, this pulmonary vein that carry oxygenated blood towards the left atrium. Okay, that is occur when it is in a relaxed, that means in joint diastole. Okay, so when this vena cava and this coronary sinus carry, I am not showing here, already in previous lectures already I show this one. So here I am mainly gives stress only with this cardiac cycle part, only with that time as well as how happens the different stages. So first, with the help of this field, that is right atrium is filled. Okay, and also this left atrium. And between this right atrium and right ventricle, valve is present. That valve is called as tricuspid valve. One valve is present, that is the tricuspid valve is present. And between these, left atrium and left ventricle, that one is bicuspid valve is present. This tricuspid, that is bicuspid. Now, in which condition now? It is in joint diastole. That means all chambers are relaxed. Now, from this right atrium, this deoxygenated blood, it is now moved to the right ventricle. Okay, like that, from left atrium, the oxygenated blood that is enter into the left ventricle. Okay, during that time, 70% of almost 70% of ventricle fill up. That means the blood which is passively coming from this right atrium as well as this left atrium, it is fill the ventricle part almost 70%, that is fill up. Almost, that is 70% fill up. At which condition? At joint diastole. Okay, and that is occur for 0.4 second. Now we'll move to the second phase, that is atrial systole. That means contraction occur in the atria part, and that is occur for 0.1 second. Now what will happen? Already in my previous lecture I called that these heart muscles are myogenic and they don't depend on the stimulation from outside. They can produce their own stimulation. Okay, so for that a node is there that is called as sinoatrial node, and that node is present here. That is called SAN, sinoatrial node, and it creates the action potential, and that action potential move to left atrium as well as to the right atrium. But in the same time, this action potential unable to move to the ventricle part. Why? Because in between atrium and ventricle, one membrane is present which prevent directly move that stimulation or this action potential to the ventricle part. Okay, so to move this action potential, another one, a small hole, that means like window like present, which is called as AVN or atrioventricular node. That node is called as pacemaker, and that node is called as pace setter. And through this bundle of his will come, and then they move to right side as well as to left side. These are called as bundle of his. Okay, then this move to the left bundle and right bundle, and finally they are distributed in the right side as well as in the left side, and finally they are aimed with some fibers. These fibers are called as Purkinje fibers, and these Purkinje fibers are connected with these ventricular muscles. That means the impulse which is generated in atria, okay, that means the contraction, that's why this atrial systole, where it is occur? It occur in the atria part. Who is responsible for that? This SAN, pacemaker, sinoatrial node, is responsible to generate the action potential. But that action potential at once cannot follow or go to this ventricle part. Okay, this ventricle part. Why? Because one membrane is present between this atria and ventricle. Okay, in between there is AVN, atrioventricular node, is present. Through this atrioventricular node, the bundle of phase is coming which carry the impulse to the ventricle part. But for that it required 0.1 second. That's why after 0.1 second the contraction start where in ventricle part. Okay, so during atrial systole, when it gives pressure, okay, then the blood will move to this ventricle. But before that, before this atrial systole, already this ventricle part, right and left, already they feel almost 70% during joint diastole part. Okay, so when atrial systole occur, then it will give the pressure and then feel the another 30% of this ventricle part. And when this atria give pressure, then the valve which is present in this inferior vena cava, which is called as Eustachian valve, become closed. Okay, Eustachian valve, that is closed. And another one, the valve which is present in coronary sinus, it is present where? This is present the valve is called as Thebesius valve. Thebesius valve. This valve also close. Okay, when this atrium gives pump, then the blood again wants to move through this inferior vena cava as well as this coronary sinus, because during joint diastole the deoxygenated blood is coming from where? From this inferior, superior, also is this coronary sinus to the right atrium part. And just remember that superior vena cava don't require any valve because they are in a slanting position like that. So they don't require any valve. So generally no backflow occur in superior vena cava. Okay, but this inferior vena cava containing this Eustachian valve and this coronary sinus containing this Thebesius valve, and during atrial systole these valves are closed. And in the same way, this blood also coming from this pulmonary veins also, okay, from this left atrium, and this pulmonary vein also do not contain any valve. Okay, so when it give contraction, these valves are closed. That's why the blood is flow only one direction, where? To the right ventricle as well as left ventricle from left atrium. Then it fill the other parts. Okay, now the action potential is coming through this SAN, AVN, through this bundle of his, then left and right bundles, and finally this Purkinje fibers. Now we are moving to the third phase, that is the ventricular systole. That is ventricular systole. In ventricular systole, that is occur for 0.3 seconds. Now, where that contraction will start? In the ventricle parts. Okay, when ventricle give contraction, then the blood wants to move this direction also. Okay, but this tricuspid and bicuspid valve will close, because when it gives pressure from lower side, this valve will close. And another, here I am showing here pulmonary artery is present, and here from this left ventricle aorta is present. Okay, so when it gives pressure, then this valve, these two valves are called as SL valve, semi-lunar valve, and that valve will open. When it will open? When this ventricle give almost 120 mmHg pressure, then this valve, SL valve, will open. Okay, and from here it will move to the lung, and from here it will move to the whole body system. Okay, now the blood now moving here, because here contraction is there. When contraction is now where? In the ventricle part. Now atria is in diastole condition. Okay, atria contract only for 0.1 second out of 0.8 second. Other 0.7 second it will be in diastole condition. Now that blood flow, okay, gradually the blood come out from this ventricle, right ventricle as well as this left ventricle. So now here there will be less pressure available. So the valve which is closed, tricuspid as well as bicuspid, due to pressure, less pressure is available. And in comparison to atrium, ventricles have less pressure, because in diastole condition also, that means in atrial diastole condition also, the blood is filled up both in right atrium as well as left atrium. So in comparison to that, atrium containing more pressure, so that valve should be pressure available. Then this valve should be automatically again, it should be open, but that is not occur. Why? Because chorda tendini, because here chorda tendini is present. Okay, this chorda tendini anchors these valves, bicuspid and tricuspid valves. It would not allow to open this valve for this 0.3 second. Understood? Because this ventricular systole is give contraction. Now this blood is moving, transporting respectively through pulmonary artery and aorta. Now when it is moving, there will be less pressure available here. And this valve is closed. Why? Because of this pressure contraction in ventricular parts. Okay, when there will be less pressure available, automatically that valve should be open again. But it is protected by this chorda tendini. It keep closing this valve, tricuspid and bicuspid valve, for this 0.3 second. That means when there is less pressure available, then time also this valve, AV valve, do not open. Okay, now after this 0.3 second contraction, now the blood is moved. That means contraction is over. Already during that time, this atria part is in a diastole condition. Now after this 0.3 second, the ventricle also in a diastole. Okay, that is called as joint diastole. That means that at that time, another 4 seconds, this ventricle also in diastole condition and this atria also in diastole condition. And again same condition occur. The blood from this vena cava and the coronary sinus, it will come and here it is filled. Okay, it will fill, and this gradually it will create pressure, and at the time this from this here this passively move and fill almost 70% of this ventricle during joint diastole. That is occur for 0.4 seconds. After that again same atrial contraction, then it will fill another 30% of this ventricle. Okay, then through this his or this Purkinje fibers, the sensation is created in ventricular part. Now ventricle is systole for 0.3 seconds. Again that blood is moved out accordingly from this right and left. When the pressure is released here, but at the same time these valves are not open. Why? Because of this chorda tendini. Chorda tendini anchors this valve, so it not allowed to open. Okay, when it will again in joint diastole, again this blood will come and again this is specifically move. In that way the process is continuous. So up to here I am covering the cardiac cycle part, and